So welcome today. This is the Edge-MHS session that we're going to be doing today. My name's Dirk Blevins. I'm a senior platform architect with Intel, and this is Vincent Nguyen, who is a HPE Distinguished Technologist. So we're super excited here to talk about a new specification that we're going to be bringing forward within the MHS workstream called the Edge-MHS. So to recap last year where we left off at, we introduced the concept and the ideas of what we were trying to accomplish. Those particular goals really haven't changed. You know, we talked extensively about how what is an edge and where does it begin? There's various different situations and various different edges that people actually identify. There's the near edge, the mid edge, and the far edge. With that said, there's different requirements essentially that occur based upon which location you're at. You know, the near edge or closer to the data center essentially has less stringent thermal requirements in some regards. It's the chassis depths are normally larger. As you move to the mid edge and the far edge, you start to get higher, more extensive temperatures that you have to deal with, and lower temperatures, minus 40 C to 60 C. And then your server depths start to get quite challenging as well for various reasons, and we'll talk to that in just a second. With that said, the requirements essentially start to diverge and get more challenging as you start to move closer to the far edge. In particular, our focus for this particular work stream, at least in our initial incarnation, is going to be around the mid-edge and slightly into the far edge. So there's been several demonstrations out on the floor of some solutions in this space of short depth chassis, pole mount solutions, and various implementations like that. So our focus is what remains the same from where we left off as last year. Now, what's driving some of these particular requirements? Essentially, when you go to the edge, there's legacy install base that occurs, and when that legacy install base occurs, you don't really get to change the infrastructure that exists there. You don't get to get more power. I was tickled watching the keynotes, and they're talking about multi-gigawatt racks or some kind of thing like that. But the reality is you don't get to do that at the edge. You get what you get, and you have to live within those power envelopes and those solutions. So with that said, common chassis infrastructure and rack infrastructure is limited to, often 450 to 480 millimeter solutions. And then the other common size is a 600 millimeter solution. In addition to that, you face in situations where you have DC and AC plants, but a lot of minus 48 volt DC. We're talking about 48 volt DC in the data center world now. This mid edge has been doing this for multiple decades now. So this is not new to them. It's just the negative version of the voltage. In addition to that, because of these short rack depths, you don't get all the space to be able to essentially use for your piece of equipment. You still have to cable in and out of the solutions. So that's where the cable routing aspects come into play. That forces solutions that's shown on the right-hand side essentially to be implemented to where you're dealing with about 300 to 310 millimeters to allow yourself to be able to cool solutions and get airflow through solutions. And that gives you a little extra room at the back and the front for cable routing and essentially the ability to be able to get air out the back to recirculate it through the solution. Now, with that said, I am very proud to announce that we decided to move forward with the Edge-MHS workstream. This is something that we officially started in July of this year. It was a group that came together of AMD, Ampere, Dell, HP, Intel, and Jabil. when we look at where we're trying to go and where we're trying to head, we are currently in development. We're hoping to get initial specifications released by the end of this year, sometime that the public essentially can be able to see and start to provide feedback on and tell us if we're doing things right or wrong, as we've heard others say as well. Then from there, we're looking to have a couple of different drops in the first half of next year, and at worst case, we would like to be a 1.0 spec by Global Summit next year. So hopefully we can beat that. We've got off to a good start, I believe, Vincent, with a lot of good conversations and things of that nature. So.
For us to accelerate this adoption and the speed of the specification, definitely we continue looking for your feedback. I think that's how we're able to move faster by accommodate requirement early on, right? And then we put it into the work stream and we start discuss and then put it in the specification. So.
Yeah, absolutely. Don't wait to if this is something you all are looking at, email me, email us. We'll get going on it and understand those things. Don't wait till Global Summit or Regional Summit or something to provide feedback, or even the specs to be released. We're willing to talk with you about the progress and how things are going. So with that said, what is our intentions for the solution? Our intentions essentially are to leverage the data center modular hardware specification building blocks wherever possible. So we don't want to reinvent the wheel. We want to use good things. I mean, we built great things in the multi-track connector that we can use. We built a ton of good things that we think can be realizable and reusable, from in the data center MHS for the Edge specification. But if you look at the blue boxes here, these are things that we know that we're going to have to do new. You can't fit the current specifications that we've defined in the data center MHS into these solutions because, if you got a 305 millimeter board and you have a 305 millimeter chassis, those things just don't line up. So we have to get into a couple of new form factors, and Vincent's going to talk about it here in just a second. But this is an important point. And then we also heard Casper and team, Todd and company, and Phil talking about the new Edge SCM solutions. One of the, in addition to it being good for AI and certain data center solutions, we can't do it without it, quite frankly, in this space. So we have to move into this new realm and this new possibility thinking. So that's why we're going to be working on I call it the Edge SCM, but it's going to be the 1U vertical form factor SCM that Casper and company has been talking about already. So Vincent, take it from here and tell them a little bit about the specification.
So Dirk already mentioned there are significant different requirement basically as far as you move away from the edge. So even within the edge itself, the requirement are also different. Because of that, we believe that our goal and objective within Edge-MHS is to define a new modular hardware component that optimize for the edge. Right, but we don't want to basically we don't want to basically create an ecosystem. It's too wide either because that really reduces the interoperability as well. So learning from DC-MHS, as you know, initial goal we have a full width design called FLW, and then we have a MDino, right? And we see there are some gap or differences between those. So the team make a strong effort, the community, the industry, to convert that into a SDino, right? To convert to solve some of the incompatibility, right? So those HPM can fit in the same chassis. We want to leverage the same concept from DC-MHS and carry forward to Edge-MHS. So with the scalability attribute of MS-Dino, we can do the same thing with MHS at a different quanta. So if you look at it, our initial thought to have two form factors, the half width and the 3/4 width, right? The reason we need 3/4 because of the chassis depth, short depth requirement, right? We need to fit the power supply plus the HPM and still maintain and meet the requirement for the edge. So by making it scalable, right, we can go, basically 260 all the way up to
365.
365, sorry, right? And then the 365 long half width can even go down to the 260 millimeter depth. So by doing that, I think we create the ecosystem that gives you flexibility to fit in the component that you need, but still allow it fit in the same chassis. That's the ultimate goal. Now, not just a form factor are different, right? The technology also are different for the edge as well. As you can see, we already talked about the HPM, right? But for the edge, motor power supply normally locate in the center. Even though we leverage the MCRPS, we strongly working with our MCRPS workstream to make sure the power supply can support reversible airflow, right, to meet the edge application. That's one of the technology that think we're going to focus and then collaborate with the power supply workstream to address and to make sure the ecosystem is ready for the edge application. And then Dirk already mentioned about vertical, right? The reason why we cannot utilize the current DCSM form factor is when you basically connect it to the HPM, we will definitely increase the depth beyond the target, right? 450, 350, or 310. So result of that, the vertical form factor is I think, the direction the team want to pursue. Now, with the edge, the goal here is also provide the cable interface to DCSM. So it's allow us to have flexibility to put where the I/O faceplate need to be, and also allow it to have different I/O faceplate configuration for the edge as well.
And that'll be a big difference between the current generations of the vertical form factor, which is kind of tethered to the front of the interface, versus this new specification. As Vincent said, we can place this anywhere and cable the extraneous I/O to anywhere else in the system, the front, the rear, wherever.
Correct. And then one of the things that we would like to basically look at from technology, what the edge looking, right? Timing is another technology very important for the telco application, right? To do that, how is there a standard way we can provide the interface of these modules to the networking adapter within the edge server itself? So there are a couple efforts that we've been looking at it. We're looking for your feedback, right, as well. And we will come up with the early draft of how we're going to do that, right? Interface between the timing domain to the standard PCIe or OCP form factor.
Yeah, and along the timing, I want to add one other thing there that, as we move into this world of artificial intelligence and things of that nature, and especially as we move into the next phase of inferencing beyond training, I do believe that people are going to start to become more reliant on tight timing, tight controls. I started my career as a controls engineer in industrial automation, things of that nature. You have to have the ability, if you're controlling a robot arm or various other things, to be able to be in a tight, controlled timing loop. I don't think people have really done that in the past, but I think precision timing is going to be absolutely critical for the future of artificial intelligence, much like it has been for VRAN and a few other things in the past.
So rather than we already talked detail about this, anything you want to add to this?
Not really. I mean, I think you've seen it 2 or 3 times now. So, but for those that haven't seen it, as we said, there's going to, just really quickly, there's going to be a new DCSEM solution that we're working on with the SCM group. I'm working on that with Glenn Hanna and Casper and all the crew. Essentially, the thought process is a volumetric, for a solution. with a couple of a minimum and essentially a maximum length and the ability to be able to fit within that volumetric, that will make you compatible. The interface will be compliant to the DCSCI from the DCSCM specifications, and that will be the path forward that will give us the flexibility to do the things that we just spoke about.
So what are the next steps?
Well, so as we start to look at these solutions, most importantly, we need your feedback. We need your responses. We need to hear from what you believe the needs are. We've kind of told you where our focus is. If you have an opportunity to be able to, or desire or need for this type of a solution, please reach out to us. We'll start to discuss some of the things that we're looking at, some of the things that we're trying to do and implement. We would love to hear what your challenges are, first and foremost, because we have a lot of challenges we face ourselves. So please join the public meetings, hear how the spec progression is going, understand where the solution space is going. We'll try to provide updates like we have for all the other specifications as we move along. In addition to that, as these spec releases start to come out, please review them. Please, provide feedback. And I think thirdly, we're not opposed to others potentially. If you feel like you can provide contribution to the work stream, we're open to entertaining the possibility of people joining the work stream. So if you feel like you can provide contribution and you feel like you can bring those things forward, please reach out to myself or Rodian, who is the other lead for this solution, and we'll see what we can do to get you help. I don't know if you want to make a final closing comment.
Yeah, sure. Another area is not just looking for feedback, but actively as a committee member, we also outreach basically to other standards like Open RAN. Is there opportunity that we can work together, right, to come up with a common solution or even leverage, right, the component across ecosystem as well? So that's the goal, right? Our goal is to enable a system that can scale and can benefit both customer as well as the product provider, right?
So I do believe we are at our time. So if you have any questions, feel free to, we'll come up here, move outside. I believe there's a break coming up, right, John? So we can take questions up front post this session if that works for everybody. So thank you very much.
Yeah, thank you very much, Dirk. Thank you, Vincent.